everybody, and welcome to this talk on bird migration. This is a talk I've given quite a few times, but it is evolving, and I've included some new material tonight. Thank you to all those folks listed who've been generous with their photographs, which I've used for this to illustrate some aspects of the talk. So where do we start? I think we start with the notion of birds as the ultimate travelers that are able to exploit the resources of the planet. And hence the subtitle, Planetary Resource Managers. I think the fundamental question is, do not ask why some birds migrate, but why do not all birds migrate, given the reality that birds are literally so mobile and so able to move around the world. So basically the statistics show that 4 to 5 billion birds fly to Africa in our summer, in the Northern Hemisphere winter in the Palearctic region, that's Europe and Asia. And 4 to 5 million birds come to Africa in their winter. The other interesting, fascinating point to look at is most Northern Hemisphere species are migrants. So in the old world, most species in Europe and Asia are migrants, and this phenomenon increases as you get further from the equator. Whereas in Africa, most species are resident or only local, show local movement or local nomadic movement.
The thing that really got me going on migration was this bird living in Centurion that appeared one afternoon, flying in from the clouds. A female honey buzzard, and that's in 2013, the date on the photo. That's in 2014, and that's in 2017. And it was actually for 7 years that I was able to observe this Eurasian honey buzzard coming back to the on its winter holiday, as it were, from its breeding ground, to exactly the same perch, literally the same perch. And it became a familiar friend, and even got used to me to such an extent that I could approach this bird and watch it, and it wasn't alarmed. That's the global distribution of this species. And we have a large overwintering population in Southern Africa, and some that don't even leave. I'll come to that. And that's one of the major migratory routes across the region. Now, there's a very interesting bit of anecdotal research here, because if you read the large Handbook of Birds of the World, they'll give you a population estimate, and I think one of the population estimates from extensive studies was about 17,000 pairs in Europe. But in Eilat, in Israel, which is one of the migration bottlenecks, as it were, where lots of birds come through, you have all this observation going on. And on one particular day, these are all honey buzzards, on one particular day, Saturday, 2nd of May 2015, they had 40,000 by 9 a.m. crossing over, and total for the day was 250,000 honey buzzards, which was really substantially more than what was assumed to be a global population at that stage. And then some of the interesting facts about honey buzzards. First of all, that's the thing that struck me was the site fidelity, and then the gap year for young birds, and the fact that that these birds mate for life, but do they actually spend their time together? So what I'd like to do is actually just show you this animation. And this is a pair of honey buzzards, the male's in blue, the female's in pink. And the starting location is somewhere in Holland. And the animation just shows the movement. Both of these birds had trackers put on them. Sorry, now I've gone back. Had trackers put on them, and this is an animation which shows the movements. So you can see the male flying around and the female flying around the home ground, and we're zooming out over Northern Europe, so we can see what's going to happen. And then come the period in the beginning of the migration, they head into Africa, they cross the Sahara, they go down into West Africa. And the female goes all the way down the west coast of Africa, while the male stays right up on the Horn. Then they're coming back. But you see how far apart they were during the winter season. She gets lost in the Sahara. She flies around. This is actually exactly what happened. The data showed that she wasn't on a fixed pathway. And is she going to find her way home? What's going to happen? Across the Mediterranean, up into Holland, and back to the nest site where the male is patiently waiting. And there they all are. So this is a fascinating phenomenon, whereby, and it's been found to occur in quite a number of different species. So Warwick Tarberton, our famous local ornithologist, did study on woodland kingfishers in Modimolle, used to be called Nailstrom, and he found that the woodland kingfishers had exhibited the same behavior between the males and females, even though they mated for life. When they went away on their winter migration, they didn't go to the same area. They were very far apart. So just to get on to Palearctic migration, this is a very old term. The Palearctic region describes vast tracts of the Northern Hemisphere in the Old World. But we can ask ourselves an interesting question. If we look at it from a South African perspective, if Cape Town is 34 degrees south, and 35 degrees south is 73 kilometers south of Cape Point. So if you stand at Cape Point at the end of the continent and you look south, you're not at 35 degrees south. If you flip the world around, where do you think 35 degrees north is? And the answer is, it goes through North Africa, south of Europe, includes parts of Southern Asia, but none of Europe at all. So in fact, we because of our geography and our politics, we have a false sense of the distribution of landmass on the planet. And the truth is that if you look at the Palearctic region, the vast amount of landmass is actually in the temperate zones, whereas in Africa, we don't have any landmass in the temperate zones at all. And then in terms of the actual surface areas of the different continents, Africa is a very vast tract of land, so it has lots of potential to host a lot of species. So if the world is flipped upside down, the southern tip of Spain would be 300 kilometers south of Cape Town. So most of the northern hemisphere landmass is temperate and has extreme winters. But extreme climes provide the best breeding conditions. And what we essentially find is the fundamental reason for this Palearctic movement is the far northern temperate conditions, which provide very good opportunities for breeding success. Few predators, ideal weather conditions in summer, long day length, and a very explosive ecology. So why is there an explosive ecology? And that's because the entire food chain descends down to almost nothing in the winter months, under the extreme cold conditions in winter. And therefore, the food chain starts again from zero. So there's always more life lower down the food chain, which means you have more availability of food in this environment than you do in temperate regions or in tropical conditions. In tropical wetlands, for example, you often find a kind of a equilibrium. You know, if you look at some permanent lakes in South Africa, I'm thinking of perhaps the Knysna area. You have just a more static, more stable kind of ecology, and you don't have a lot of excess food, so you find bird numbers being quite low. If you compare that to the explosion on a floodplain in spring after rains on the Nails Fly, for example, it's because you have this incredible explosion of the food chain, and you have a lot of extra food availability. So just to have a look at Southern Africa and our migration situation with all our species, we get 83 species from the Palearctic, and we have 57 intra-African species. And all the other species doesn't mean they're not migratory in the true sense of the word, but they occur basically in our region all year round. And all Palearctic migrants, when I say virtually, I can't even think of examples, are non-breeding in the southern African part of their range. So we don't have any Palearctic migrants that breed here. There have been some breeding attempts by species like common house martin. And then, of course, we'll come to European bee-eater, which is an interesting case. So what do we have in terms of main migration mode is intercontinental, mostly north-south. Continental, within the continent, intra-African, these birds are moving from the tropics to more temperate regions, like the red-chested cuckoo, for example, which breeds in southern Africa. but overwinters or has another different season in a more tropical area where there's the better availability of food in our winter. And then we have local and altitudinal migrations, and we'll come back to some of these. And then breeding versus non-breeding migrants. So we have in Southern Africa the intra-African breeding migrants, and we have the Palearctic non-breeding migrants. And then the whole fascinating issue for me is the question of nomadism. And recently spent quite a lot of time in the Northern Cape, in the semi-arid region known as Bushmanland, involved in wind farm surveys, and was just struck every single day of field work at the incredible phenomenon of nomadism in an arid environment. But then to look at a different angle of nomadism, of course, you have the wetland species. They're not following. They're not in an arid environment, but they're in an environment with very dynamic and unpredictable weather patterns. So this Allen's gallinule arrives in large numbers in South Africa when conditions are good. At other times, it's completely absent. So just to summarize, some of the Palearctic migrants we get in Southern Africa would be storks, birds of prey like common buzzard, hammer falcon, then some rallids, spotted crake, corn crake, both being non-breeding rallids, those, and then a whole bunch of shorebirds and waders, for example, wood sandpiper, ruff, grey plover, etc., black-winged pratincoal, terns and gulls, particularly the white-winged terns and some of the gulls, a whole bunch of cuckoos as well. Sorry, in terms of Palearctic migrants, just Eurasian cuckoo, or common cuckoo as it's called, and the European bee-eater. And then passerines, we have things like European golden oriole. We have a whole variety of swallows, barn swallow, sand martin, house martin, and a whole lot of warblers. And that's been one of my focus, one of my interests for a number of years, and we'll come back to that. Things like spotted flycatchers, redback shrike, yellow wagtail, and tree pipit. And then if we have a look at common cuckoo, just to give you some examples of the kind of patterns that we're looking at, which is a non-breeding Palearctic migrant, and it usually arrives quite late in the season, and that's probably because we being in Southern Africa, these birds don't have to get here in any particular fast pattern, so they probably move fairly slowly across suitable overwintering habitat and only end up in Southern Africa later in the season. Barn swallow, one that's been the subject of a huge amount of research, and is a cosmopolitan species with different forms in the Americas and in the Old World, an extremely well-studied species and one of the indicator species for migration changes with climate change. So here we have a barn swallow, then we have just a seasonal occurrence for barn swallow, a Palearctic migrant, and greater striped swallow, an intra-African breeding migrant. And this is one of the trends you can see right across the spectrum of migrants, and that is that breeding migrants come earlier and leave later than non-breeding migrants. So the greater striped swallow is basically away from South Africa, much shorter period than the barn swallow. And that is because there are a number of factors, but probably the most obvious one is that it has work to do when it's here, and that is to breed. So the breeding cycle is quite long. Many South African species, as opposed to Palearctic breeders, breed more than once, and greater striped swallow, I think, is known to breed up to 3 times in a season. So it'll start in late August, and it'll work through, and it'll still be feeding young in May in many years. So you'll see that totally different pattern. Whereas barn swallow is literally just escaping from northern hemisphere freeze or suitable conditions. So it's moving across a much larger part of the world. So it only tends to only spend a shorter period of time on the breeding grounds. Now, shorebirds are a little bit different. Even though they are non-breeding migrants, they seem to migrate much more quickly. So we start getting a lot of shorebirds like wood sandpiper quite early in the spring. And this is a map showing rough migrating from the Palearctic into Africa, and just all the locations, because they tend to congregate in very large numbers in certain areas. Then we're talking intra-African migrants to southern Africa. We've got about 60 species, with things like yellow-billed and black kite. I still regard them as different forms, very different patterns. Yellow-billed breeds here, and black kite doesn't. Hallberg's eagle, which is a breeding migrant. And then we have all the swallows, the reed warbler, African reed warbler, and I say P because it's a partial migrant. In some areas, they don't migrate as you go north in the region. In other areas, they do migrate. So your African paradise flycatchers on the far east coast, on the low veld, and in Mozambique, often don't migrate. And in fact, you have some of those areas hosting paradise flycatchers from further west and south. Dusky lark, which is a short distance intra-African migrant, various cuckoos, kingfishers, bee-eaters, and of course African pitter as well. And then we have the interesting phenomenon of species which show a variety of different migration modes within the region. And here is the beautiful little dainty fairy flycatcher. And it's been a very popular focus of birders in the wider Gauteng area around Johannesburg and Pretoria, because they come in winter. And even though it's not particularly well documented, there's no doubt that these birds are altitudinal migrants from the high parts of the Drakensberg Massif. So the biggest breeding area in the eastern part of the country is basically the highlands, up 2,000 meters and above of the Lesotho highlands. But that's being high in altitude, that's very cold and inhospitable and dangerous in winter. So then they move down in altitude and also northwards, right up to Polokwane and into Mozambique, pretty widespread. And that's the distribution map from SABAP, the South African Bird Atlas Project, a wonderful citizen science project which has collected a vast amount of data. And interestingly enough, because of coverage, of course, they don't show that many birds in Lesotho. But you see that great big population, or that area up here around Gauteng, where you've got high levels of coverage, so lots of citizen scientists, and you're seeing a lot of quite a high reporting rate. And then, of course, if you go to SABAP, it also shows the seasonality, and you can see that they arrive usually in April and they depart in September from most of these northern areas, which matches the breeding cycle. And then, of course, one of my most fascinating birds to me is the mountain pipit, which also occurs mainly in the Lesotho highlands. That's its distribution, not as very well known. 2010, and this bird is the overwintering grounds are really unknown. There are few records, and part of the problem is being a pipit, it's extremely similar to African pipit, difficult to locate, difficult to identify, and most birders are not looking for dull pipits in the winter months. So that just shows the breed mostly around Lesotho and then parts of the mountainous Eastern Cape where they breed. The blue spot east of Pretoria up here at the top of the map is where we found a small population in early October. I think they were on passage, but that's actually that bird that was photographed at Isimvelo Nature Reserve to the east of Pretoria. And then the question is, well, where do they go? Because there's been allegations, or there's been all kinds of rumors that they actually go, that they summon the Northern Cape at some times of the year, but this is not yet documented. So migration, while we know a lot about the basics, there's just so much that we don't know. And one of the fascinating things to me, and I think you can see this in action in many cases, is the leapfrog phenomenon. So this is one of several migration patterns. And it's been observed in very diverse groups. For example, in golden eagles in North America, research has shown that you have essentially birds that breed much further north tend to migrate further south than the birds that breed less further north. In other words, they actually go over, they pass over those other central populations. So if you take the Palearctic example, birds that would breed in Scandinavia and would migrate to southern Africa, whereas birds that breed further south in Europe would tend to be more in Central Africa. I mean, that's just a very broad generalization, but you get the idea. And those that migrate that are in the further north they are, the shorter the breeding season tends to be. So if they're further south, so for example, if they're in the Mediterranean, they have a slightly longer breeding season, and they would then migrate more slowly and have a shorter migration, whereas those going way south would have a longer and faster migration pathway. So here is basically some of my observations to justify this. I think there's lots of theories about why there's a leapfrog process. The theories are mostly to do with ecological competition, whereby basically birds have to disperse, and those breeding further north go further and they have to disperse because the other areas are already occupied. Although I'm not exactly sure that that's the case in some of the examples that I'm going to give you. So greater striped swallows, we can actually extract that data from SABAP and from BirdLasser, which I'll come to. The Cape bird, they breed as far south as Cape Town, and we have in the northern Highveld of the country around Johannesburg, we have those birds that breed in that area. And those are different populations with different migration routes. So what we find is that the Cape birds come earlier. They come back from their overwintering grounds in Africa before the local breeders arrive. So you get early Cape greater striped swallows in flocks, and the same applies to pearl-breasted swallow. And then what we're seeing with warblers, lots of new warblers showing up in the Cape, which really excites the Cape Province listers. And this has happened historically because they're breeding further north, and they're therefore overwintering further and further south. So this is a fascinating species. The Amur falcon has the longest migration pathway of any raptor on the planet. Breeds in the Amur Basin, China, Mongolia, Russia, and then migrates down into Southern Asia from India and Sri Lanka, then takes an ocean hop to East Africa and ends up in Southern Africa from Zambia, Zimbabwe, Botswana, and South Africa. And that's our distribution map in South Africa. So what I've noticed traveling down from Gauteng to the Eastern Cape is that the birds down here are staying much later. So these birds have already departed. So the further north bird, the birds in Harare and the Transvaal have already left. They're gone in late March. But these here are still here in April in the Eastern Cape area. So that's an example of leapfrog migration. And just to show some of the incredible data from tracking of Amur falcons, that's the Amur falcon route that it takes, and those particular birds ending up in Botswana. And if you go online, you can find a lot of the satellite tracking data, which is absolutely fascinating. So then there's this thing of nomadism. So what is nomadism? So what's interesting to me looking at it now is that I think the roots of our ornithology, our classic ornithology, are in temperate climes. We have dramatic seasons where you have hot summers, long periods of daylight, and extremely cold and miserable winters. So there's kind of this assumption that that's the main pattern of the movement of birds. And you see it even with the names of birds. I mean, we have the Eurasian bittern, which occurs as a resident breeding bird in Africa, but why is it called Eurasian bittern? And I think it's because there's still this assumption, and I've actually met ornithologists that still believe that great bitterns are Palearctic breeders that migrate to Africa and they don't breed here. And then they migrate back every season. And that's certainly not the case. We know that from the data we have, particularly from Mozambique with great bittern. And then I think there's been some very interesting studies on dry country birds and nomadism. And what we find is that in arid regions, if you take South Africa, if you take the Great Karoo and Bushmanland and Northern Cape, that's where you find a whole lot of species that show basically nomadism as a way of life. So your classic nomads, grey-backed and black-headed sparrowlark, Sclater's lark. Everybody's looking for Sclater's lark, but you can't find it because it's a nomad. It doesn't follow specific patterns. It shows up in some areas, some years, and other years it's absent because the conditions are not good. Ludwig's bustards are very, very nomadic. Greater kestrel, I think, is also nomadic. You don't see it as a nomadic bird, but when the conditions are good, there are far more greater kestrels breeding in the areas than typical. Quails. When I was at the Northern Cape now, the place was crawling with common quails and common button quails. And interestingly enough, we got a lot of out-of-range forms from the Bird Atlas project for both of these species, but they're obviously there in large numbers, having being in a season with good rains, and they're breeding. So they are breeding on a nomadic basis according to conditions. South African shelduck is one of the classic nomadic birds that is very mobile and travels around. So I believe there's very little research on the evolution of nomadism versus fixed routes. And in general, migration studies are focused primarily on birds where you have a kind of a fixed pattern. And even if you read some of the papers now looking at climate change, the sort of starting point is that birds have fixed patterns, and they're having to then adapt dramatically to climate change, and there's this kind of stress on birds. And I wonder if that's really the case. If in fact, and I'm going to explain why. I think there's an interaction between fixed routes and patterns in bird movement. So birds, the more clear cut the seasonality of the changes in environment is, the more fixed it is, the more fixed their routes. But even birds which show very fixed routes also show some degree of nomadism on their non-breeding grounds. So what I'm saying is that having a fixed pattern and then being able to be flexible are two complementary adaptations in birds. And even palearctic migrants that are believed or seen to have pretty fixed patterns actually also show nomadic behavior. So my example, having studied palearctic warblers at Zarkale Drift for close on 20 years now, what we see is that individual birds will return to individual locations. So they show a high degree of site fidelity. They come back to exactly the same bush. And if you take the example, say, of river warbler, which everybody's always very interested in finding, you go in 1 year, 2004, 2025, vast numbers of these birds. Those were particularly good years. But they're not all there the next year. There won't be the same numbers in all likelihood, and certainly from 2004 to 2025 and all the intervening years, there were far fewer birds. But what's interesting is even those fewer birds show site fidelity, but then obviously some of the birds are not showing site fidelity because they're not coming back in the same numbers as the previous year. So we've seen this with a number of species. And of course, it's long overdue that I actually write up some of this research and some of these observations. Common white-throat, another species that shows tremendous variance in seasonal occurrence. In other words, they're nomadic because in years when the conditions in a particular part of Africa are good, they're there, and in other years they're not. The bottom line is that very little is known about local movements of African birds. So just to go to a paper, I forget the author. This is a very interesting article written quite a few years back, looking at all the nomadic species in the Karoo. And what's fascinating here is that if you take all the species in South Africa and you were to give them a rating on how nomadic they are, the ones that are most nomadic are all in these dry western areas. So that's very interesting to see the interaction with aridity, or let's say climate instability or climate uncertainty, and nomadism. And in the case of palearctic migrants, to go back to my warbler example, even though the north-south pattern between the palearctic and southern Africa is very clear, when they get here, they're still in Africa, which tends to have very unpredictable climate cycles on an annual basis. And another example would be on the subtropical east coast of South Africa, where you have periodic storms and cyclones, and a lot of wetlands created specific years, and then other years it's dry and there's no wetlands. So there's a tremendous, even in Miombo woodlands and in forest habitats in the eastern part of Mozambique, which is impacted by cyclonic storms from the subtropical Indian Ocean. You get dramatic differences in bird populations according to what's happened in the last season or even the last couple of seasons. There's sorts of ebbs and flows, which we know very little about. There's the black-eared sparrowlark, one of my favorite nomadic species and one of the most difficult birds for people to find, because with nomadic species, pins don't work. You can't get a pin for a black-eared sparrowlark because they're not at the same place every season. They move around. And of course, little beauties like the black-headed canary, which is also highly nomadic. And even birds which I think are regarded as more sedentary, like this beautiful cinnamon-breasted warbler, one of my top 10 favorite birds. Having spent some time in the Northern Cape this year, I'm convinced that the high numbers that I found were specifically linked in certain areas where they had tremendously good rain. So they also show local movements and nomadism to take advantage of good condition. But just back to this whole issue of migration and climate change, there's been a lot of research. And I think the barn swallow is probably one of the species that really, has because of the amount of data on barn swallows, both in the Americas and in the old world, that there's a lot of research and a lot of clear trends. So what you're finding in Southern Africa is that barn swallows have arrived on breeding grounds earlier. So they have an earlier spring in the northern hemisphere due to warming of the climate. So they basically have therefore a longer breeding season. Sorry, I'm basically telling the story in reverse. They arrive on the breeding grounds earlier, and they leave South Africa earlier. So basically, because of the warmer climate in the northern hemisphere, the warming up, they're breeding earlier, and therefore they're leaving South Africa earlier. And that's a complex, extremely complex process, which I think we really don't know very much about. And here's an interesting case. The European bee-eater, so-called European bee-eater, now has a substantial breeding population in Southern Africa. And I don't know if we really know about the genesis of this breeding population, but we do know that it hasn't been there for very long. And it certainly seems to have increased in the last few decades. And this map doesn't really adequately present it. I think the breeding area in the purple down at the bottom is where they actually breed. Not this map, I think, is incorrect. And then the Southern African breeders are then moving into Africa, and they're intra-African migrants. Tracking studies have shown that those birds that breed here are not going back to Europe anymore. So they're no longer European bee-eaters, they're now African bee-eaters. And obviously, over time, they would shift away in evolutionary terms from their European counterparts that are coming to the same areas to overwinter, breeding still in Europe. Just a small little, I was going to include a whole lot on research methods and how we know so much about migration, but I think it's difficult to fit it all in. But something that's absolutely fascinated me, and the potential of which I think has blown open migration research, is the arrival of geolocators. So geolocators are like little bird rings that are put on birds. They're not satellite transmitters. They're not satellite. They don't emit a location, which is then picked up, a signal. They don't emit, so they can be very small, down to a gram, even less now. I think 0.3, 0.4 is what they get down to. And what they do is they have a solid state memory, and they have a light sensor and a very small processor that basically measures light against the timestamp. So every few minutes it records the intensity of light. And they must be recovered. So what you do is these geolocators are fitted to birds at their breeding grounds, and the fact that birds show a high degree of sight fidelity enables one to recover the geolocator after the season. So basically, if they're breeding in Europe somewhere, or in Modimolle, as the case is, the study that Warwick Tarberton was involved with, then when the birds come back to their breeding location the following season, the birds are recaptured, the geolocator is removed, and then the data is basically taken off. And they have a long lifespan, so they record the whole season. And they're not very heavy, so they're very minimal impact on medium-sized to small birds. So they've been used on swallows and in North America, and they've shown a tremendous improvement in our knowledge of migration. Has been absolutely phenomenal compared to old traditional methods of like bird ringing, which really can't produce any migration data other than a start point and a finish point. And you have to find the birds usually have to die in order for that thing to be recovered, and vast numbers of rings are just never recovered. It's a very, very much a shotgun approach of catching large numbers of rings. I wanted to actually, I meant to put in a slide just showing knowledge on European hoopoes, 50, 60 years of ringing versus one study recapturing only getting 2 geolocators back, which completely blew the existing knowledge about Eurasian hoopoes movements in Africa out of the water completely. So basically, I'm going on to just talk about some of the most incredible migrants, just because I think one of the aspects of migration is just how remarkable it is. So in ancient times, people were aware that birds disappeared and they went on migration. And there were these ideas that, in fact, the large birds transported all the small birds, because people could not conceive of the fact that small birds could actually cross even the Mediterranean. I mean, we now know that that's an absolute breeze for birds. Birds have far more physical capability in terms of long distance migration than we can comprehend. And in fact, the history of migration research and knowledge has been a repeated story of, no, birds can't do that. They couldn't do that. Well, actually, yeah, the evidence says they do. They do that. So we have to change our theories and change our perception. The willow warbler is our smallest palearctic migrant in southern Africa. Weighs from 7 to 15 grams, about 80 million pairs. The longest route from South African Cape to Siberia is about 28,000 kilometers round trip. And vast numbers of them. 80 million pairs, the bulk of them, I think all of them, come to Africa. So we have large numbers of them in the woodlands and bushveld of South Africa. And it's one of the birds where you see this remarkable process taking place, which is about metabolism. Because, of course, if a small bird like that's going to fly 14,000 kilometers in a couple of weeks, it needs a lot of energy. And what's fascinating is how the Palearctic warblers, I think, are well known in this regard, and there's been lots of research, how they build up fat reserves late in our Southern African summer seasons. So from about February through to March, most of the willow warblers leave in the end of March, early April. These birds start feeding up, and they literally become frenetic in putting on weight. And if you're a careful observer and actually watch what's going on, you will see them getting fatter. You will see that the birds that have arrived in October are thin, and then they seem to be thin most of the summer to January. And then after that, just have a look. They definitely get a lot fatter, and they put on up to 100% body mass for the journey. Here's a not a great photograph, but this is just an observation of a marsh warbler desperately trying to eat this termite that was in the spider's web that was still alive, but very careful about not getting caught in the spider's web. And we watched this desperation to get hold of this morsel for probably 7 or 8 minutes. And the garden warbler, this is a wonderful garden warbler photo taken up at Katima Malilo, the bird bathing in the the drops of a sprinkler by Albert McLean. But there are some fascinating studies on garden warblers, which also indicate a change in dietary habits and a change in metabolism in preparation for the long journey. So Sylvia warblers, like garden warbler, Eurasian blackcap, are more omnivorous. They really do enjoy fruit. And just the other day I was in Mozambique and saw a garden warbler eating some berries of a species of fruit somewhere at the coast. So I still need to figure out what it is. But what's fascinating about this is that they become more frugivorous. In other words, they eat more sugar in the period that they want to migrate. So they become almost diabetic, and they put on a lot of weight. And then when they actually migrate, the metabolism switches over to being fat burning. And by the time they land at the other side, they no longer have the same lust for fruit, because the fruit actually serves the sugar and the way that the body handles insulin resistance and the deposition of sugar and the whole energy cycle actually changes in garden warblers according to the migration cycle. And I think there's still a lot of research to be done here, but it's absolutely incredible how the entire metabolism is geared to the migration process. Okay, so we talked about the willow warbler flying 8 to 14,000 kilometers, and they come back to exactly the same spot. And they also show high site fidelity with the ringing recoveries in South Africa. Birds caught in exactly the same place year after year. An Arctic tern that migrates 25,000 kilometers each year, and that's not including all the normal flight that it does while it's feeding. Fascinating. This is one of the classic stories. A Welsh Manx shearwater from Wales was captured in Wales, put in a box, flown to the US, released on the East Coast, and bingo, was back in its burrow on Skockham Island before the newsletter announcing its release had reached the subscribers. So that's one of the incredible things about bird migration. We know about navigation, which I'm not really going to go into in depth. But the fact that birds can orientate themselves globally as to where they are, even if they go to some place that is completely unfamiliar, where no Manx shearwater has ever been, not as far as we know anyway. And then this is this is a world record a couple of years ago. It's now been surpassed by another bar-tailed godwit. This is E1, and E1's route, and this was a couple of years ago. When this actually was documented, it was quite a fascinating story, because the scientists who were observing it, sitting around the computer watching the data coming in, they were absolutely amazed that it flew all the way to China, did that 10,000 kilometer trip in March, and then spent some time just feeding up there, and then another shorter hopped across to Alaska, and then of course there was the breeding season, and then in August it took off. And the narrative was that when it took off and it started flying over the Pacific in a straight line, the comment was made by the researchers was, it's going the wrong way. It's going to get lost. It's going to die. How can it do that? It can't just fly straight over the Pacific. But that's what it did, and we now know that's what they do. The bar-tailed godwit is the champion, and recently another bird also similarly tracked, I think, got over 14,000 kilometers in direct flight. So some notes on migration methods. So we have very different methods of moving over vast distances, whether birds are large or small. So you have birds that catch thermals like your raptors, like the honey buzzards we saw earlier, and then we have direct flight from passerines and shorebirds. And then we have some birds which do step migration. So in other words, they fly to a particular area, then they feed a bit, then they move on. And then diurnal versus nocturnal. So most of our small passerines, I think, migrate at night, usually in groups. They migrate collectively. Navigation, it's difficult to cover all of this, but I think the bottom line is that birds see the world with a superior sensory perception than we do. And they have a very array of navigational equipment or tools that they use to navigate. So we know that they can navigate like compass in a direction. They can go from north to south or east to west, or which any particular direction they have to go. And then they can also do locational navigation. In other words, when it's in a more dynamic situation, actually get to a particular place. So we're talking about the position of the sun and then the biological clock. So those are key elements. Biological clock in terms of the bird's sense of time, and also picking up of cues like the length of daylight, etc. Position of stars, I think this has been pretty much proven, and then the magnetic field providing an underlying navigational system on which to move in the compass direction. Landmarks along the way and smell are also known to play a role, particularly with I mean, just an example would be some of the rallids that are nomadic and that they don't always go to the same place, so they would use smell and sound to locate suitable habitat. So there's an overall inbuilt genetic plan for many species that have routine systematic migration patterns, but then that has to be learnt and modified and adapted to the conditions, to the situation, to the wind. Birds don't migrate exactly the same every time because they have factors that they have to consider, like wind, temperature, storms, all kinds of things. And they then have to invoke the positional navigation through the learned process. So something that's quite fascinating and not often really, I think, appreciated by certainly South African birders is, would you migrate? Would you go all the way if you can't breed? So what we're really talking about here is once birds have fledged and they're now mobile, they're now independent, they're no longer under the care of their parents, and these are migrant species, what do they actually do? So these are 3 examples, and there are many more, of species that will migrate the first season. So from their Palearctic breeding grounds, they will migrate to Southern Africa. Osprey, bar-tailed godwit, crab plover. But then that second season, so these are, you can see in the crab plovers, the grayish ones are the juveniles, the immature birds down the bottom. But they, in terms of the fact these are all fairly large birds, they take quite a period to reach sexual maturity. So they're not going to breed. If they were to, after the first overwintering season, migrate back to the breeding grounds, they wouldn't actually breed. So what we find is that they then exhibit what's called the gap year phenomenon. And basically, these are a whole bunch of species that show the gap year phenomenon, which means they'll migrate to the non-breeding grounds with the kind of in following the adult birds, and then they'll take a break. That first season, they will not migrate back with the adults, they'll stay behind. What's fascinating to me is I've had the opportunity to observe a lot of crab plovers at San Sebastian Peninsula, the sanctuary in Mozambique, and it seems that there are a couple of adults that stay with these young birds, almost like to look after them. And there's a similar sized flock in that area every single winter, usually about 50 birds, and there's a couple of adults as well. So that's something we don't know, but maybe that's the case. But here's just a whole bunch of them. The larger waders like bar-tailed godwit has been quite well understood due to citizen science in the form of quack counts in the West Coast National Park, for example, where 17% of the total counts in summer are still present in winter. And that 17%, nearly 1 in 5, are assumed to be the first year birds. So here we go. What is the impact of migration on ordinary people? I must say that in my interaction over many years with people who are not birders, migration is one of those things, one of those phenomena that just grabs people, even if they know nothing about birds and have no interest in birds. And if you look at, ancient history and folklore, migration of birds has fascinated humans forever. There have been all kinds of theories, there have been all kinds of explanations. as to why and how migration works. And because it's so incredible, bird migration leaves us in awe as human beings. We just can't comprehend we can't comprehend the scale and the vastness of this achievement, whereby tiny birds basically utilize the whole planet as their resource field, where we just can't comprehend it. So, and I think even basically all birders are interested in it, and it also relates to something deeply internal as human animals, and that is that the changing of the seasons is something that we all look forward to and appreciate and enjoy. So we all love the onset of spring, but what is the most obvious one of the most obvious signs of spring is the arrival of birds, the singing of birds, the singing of Palearctic migrants. Every single year that I've been on birding forums, people are talking about, have the red-chested cuckoos arrived? Have the dead cuckoos arrived? On all the forums, there's that discussion. So for this reason, and then of course, because of this, there's a massive amount of data being collected by citizen scientists. So eBird, and it's do yourself a favor and go onto the eBird website and just go and look at the migration material. Of course, eBird is very popular in North America, so there's a vast amount of data being collected. So this basically is a visualization of barn swallow abundance through the season. So what you can do if you go to this page on eBird, it's easy to find, is you can scroll through the week of the year and you'll see where the birds are. So it's absolutely a wonderful way of presenting the information as well. So I believe that migration has the greatest potential of issues in relation to bird to involve people, ordinary people, in citizen science. And to this end, I've been interacting with BirdLasser to launch a bird migration project in Southern Africa. There's a huge amount of potential to involve people in a migration project because it's fascinating and everybody wants, and it's so easy with smartphones and apps these days. People are using them to log all their birds on apps like eBird and BirdLasser. There's a vast amount of data being collected, but at the moment it's not been used at all. BirdLasser in particular has quite strong standards of privacy, and birders have to opt into specific projects to allow the data to be used. So this is the intention in the next couple of weeks, that there will be the launch of the BirdLasser bird migration and nomadism project. And I think we're specifically maybe more interested in specifically in South Africa to look at regional migrations and how birds move. And there's even things like sunbirds that show tremendous movement on the region we don't fully understand. So that's BirdLasser. It's a fantastic app. A lot of people I know use it just to record all their birds. Very user-friendly. And the great about it is once you've recorded a bird on BirdLasser, you can always go back to that record, find out where it was, it's the location, everything. Very user-friendly and very, very reliable. I say to people, it's the best way to keep your bird list as well. So I think basically I look forward to taking this issue forward, and also people would like to give me feedback and interact with me about this question of a citizen science project in relation to migration. Please feel free to get hold of me. So thank you very much. There's a background of tremendous flocks of, I think they're mostly Tibetan sand plovers at the sanctuary, San Sebastian Peninsula. Thank you. I think we've got time to take some questions and discussion, comment.
Yeah, thanks very much, Etienne. Much appreciated. A great talk as usual. People want to ask questions, please just type them in the chat.
It's nice to see all the citizen scientists there. People like Sue Ertley has been going at it for decades, and Christo, who's traveled with me a lot. isn't migration just the most incredible thing? Doesn't it? Don't we think there's so much more potential to involve people in birding through migration? I'm not.
Are you reading the chat, Etienne?
Sorry?
Are you reading
Yeah.
the chat?
I can now see it, yeah. It
Okay.
took me a while, but I can see it. Thanks. Maybe I answered all of them.
I think you just covered everything.
No, there's a lot more to cover. I actually cut about 20, 30 slides out of my old presentation, but I added a few new ones. So, yeah.
It seems like there's just no questions.
Not sure if that's a good or a bad sign.
The people are still here, so
Yeah, I think just maybe if anyone can answer this question or this question of altitudinal migration, just how much are people aware of it, in the South African context? I mean, but elsewhere for North America and so on, I don't know. If someone can just pop a thing in the messages and just tell me, because to me it's absolutely fascinating, but there's not much written about it.
yeah, I was going to say. I mean, what I know about it from going birding with you. There's very little written about it.
Yeah, so obviously we've got to start writing some more. Yeah, Elizabeth. So basically, I think what you find with altitude is that altitude mimics, in a sense, the phenomenon of latitude. So if you go to very far northern parts of the world, if you go to to Scandinavia, for example, then you have extreme conditions in winter. Whereas if in Africa, if you're at the equator but you're on Mount Kilimanjaro, you also have extreme conditions of winter. So what we find is that altitude creates this diversity or change in the climate seasonally, which is much more extreme than where you're close to the sea level. You don't have that extreme. So basically, the more topography you have, in other words, the more mountains you have in a region, the more you have altitudinal movements. Yeah, I see Mark's asked a question about Cape rock jumpers. So that's an interesting one. I don't know about migration, but Cape rock jumpers are one of those species that in the Cape, the very southern tip of Africa, are close to sea level. But as you move further north, they're more high altitude species. Collins asked quite a difficult question there. Yes, okay. So what Colin's saying is that a lot of birds start a movement based on the light. So we know that birds commence coming south or commence going back based on daylight hours. It's basically a program thing. When the daylight gets shorter, they will then go back north. And what he's saying is that the changes as a result of climate change don't match this. So that's very interesting. I thought, I don't really know that much about it, but I suspect that that what we're seeing is that the light, the photo period, as you call it, is not the only factor determining when birds depart. And in evolutionary terms, what might be happening is that the birds that leave earlier, because the photo period is not fixed. So if you look at marsh warblers, for example, in the Limpopo, they don't all leave the same day. So the photo period, the incidence of daylight impacts on different marsh warblers differently. So some will leave in the middle of March and others leave in the first week of April. And perhaps what we're seeing is a simple evolution, that the ones that leave in the end of April are doing better than the ones that leave in March. And you're seeing that sort of change, with having more breeding success. So I don't really know, but I think that I think birds are adapting in more complex ways than we understand. But thanks for that, Colin. Very interesting thought.
Yeah, it's interesting that, what you said there about adaptation, and because of course there's adaptation in the genetic and evolutionary sense, but organisms can also be sufficiently flexible that
Yes.
they give the impression of adapting when in fact they're just flexible.
Yeah, yeah. Sorrel's asked about reverse migration. So this is a phenomenon where birds basically just get the whole, I think the whole compass direction wrong. So that's one of the elements of navigational capabilities is the compass navigation, whereby birds from the northern hemisphere would go south at a certain season. So what we and reverse migration is very, very interesting to twitchers, because a lot of the rarities we get are birds that have gone the wrong way, and it's normally thought to be associated with shifting magnetic fields on the planet, which literally confuse the direction. So, for example, a recent example would be that collared flycatcher in Bushman's Neck down in KZN. Full breeding plumage, male, obviously should have gone north and instead went south, and then ended up somewhere where it's just looking for some sort of habitat where it can subsist, and ended up staying there for several weeks in that one place. Yeah, I don't know, Colin, that's an interesting question. It could have to do with the birth date. So, if a bird is an offspring of parents that bred earlier, it might have a different photoperiod evaluation. I mean, absolutely. I don't know if there's detailed research on that, but it would make sense. It would make sense that there would be some interaction between different breeding times and the photo period evaluation that happens. So the photo period evaluation is literally, it's not a conscious thing. It's just literally that the experiments have been to put birds in enclosures and artificially change the daylight hours. And then what we see is that as you shorten or lengthen the daylight hours, the birds start getting agitated, and even the metabolic processes that change in order to migrate lead to a point where the bird shows readiness to move, and that's dependent on the light. So that's the photo period evaluation that Colin is referring to. Well, thank you very much. I don't know if there are other questions that I missed there in the.
No, I think you got them all.
Yeah, thank you for those. Very interesting. And of course, there's lots to learn. There's tons of research out there on very specific subjects. So it's a learning curve we're all on. But an absolutely fascinating subject, and hopefully we'll see all of you guys in the field at some stage, or interact with people talking about migration. But I mean, I think the two most important new points that I wanted to make in this particular presentation, as opposed to some of the other talks, were one, that I think nomadism is a particular phenomenon in African birds in arid regions that's a little bit under-researched and very poorly understood, and applies to a lot of our birds in Southern Africa. And the second is that I think migration as a means of mobilizing people in birding and being more aware of nature, and actually as citizen scientists, is absolutely massive. It has huge potential. So having said that, thank you very much for attending. Thanks, Derek, for hosting.
Thanks, Etienne. Thanks very much.
Derek, do you want to tell us about the next webinar?
That's a good question. The next webinar is about to be told to you as soon as I open my web browser.
Sorry.
I closed it because I was going to shut down my computer as soon as I was finished with this. Oh, the next webinar is some dude by the name of Derek. Next month.
Oh, Derek, it's you.
Yeah, me. It's going to be talking about the evolution of birds during the Mesozoic, primarily during the Mesozoic, but also something about up to today as well. So we'll be looking at all kinds of things that make birds birds and find out when those things evolved and under what circumstances and in what lines they evolved and whether they evolved more than once or just once and what it all means in terms of the birds that we have today. So yeah.
Thanks, Derek.
And that
good
will
night
be
to
the
everyone.
20th of November. Thanks, everyone. Bye-bye.